Welcome to Best Academy TV. In this video, we're gonna focus on dynamics, that is Newton's laws of motion. But before we solve some questions on Newton's laws of motion, let's know what dynamics is. Okay, please write. Dynamics is a branch of mechanics. Dynamics is the branch of mechanics that deals with the study of motion and its causes. That deals with the study of motion and its causes. Okay, before we move into the laws of motion, let's know what causes motion. Okay, so in our elementary knowledge, we are told that what causes motion is force, but that is not the only thing that causes motion. So what causes motion is force, and mass. What causes motion is force and mass. Please take note. So in this video, I'll be breaking down Newton's law of motion with its concepts to enable us to solve advanced questions. So all you have to do here is to hit the subscribe button to get all questions on Newton's law of motion. Okay, so let's consider the first law. Please write. Let's consider the first law, class. Please write. Newton's first law of motion. Newton's first law of motion. So before we solve a question here, class, let's know the statement. Please write. It states that an object remains at its state except an external force is acted on it. Newton's first law is also known as law of inertia. Newton's first law is also known as law of inertia. So if you are asked to state law of inertia, it's the same as Newton's first law of motion. Please take note. If you are asked to state the law of inertia, it's also known as Newton's first law of motion. Okay, so let's know what inertia is. Please write. Inertia is the tendency. Inertia is the tendency for an object to remain in its state. Object continue to remain at the state of rest, or the object continue to remain at the state of motion. That particular tendency is called inertia. Please take note. In this particular law, there is no mathematical formula here. It means that there won't be any solving here. Okay, so now let's consider the second law, that is Newton's second law of motion. Let's consider the second law here, Newton's second law of motion. Now let's take the statements for Newton's second law of motion. After then, we'll take the mathematical formula and we solve an advanced question on Newton's second law of motion. Okay, now let's take the statement, please. It states that the rate of change of momentum, it states that the rate of change of momentum is proportional to an external force. It states that the rate of change in momentum, the rate of change in momentum is proportional to an external force. From this statement here, class, from this statement here, let's write the mathematical expression of Newton's second law. Okay, they said the external force is directly, from the statement here, class, that the external force is directly proportional to the change, to the rate of change in momentum. Of course, change in momentum is this, that is mass into V minus U. The word rate means that that particular quantity is being divided by time. Please take note. So it means that this change in momentum, this word rate here, this word rate simply means that this change in momentum will be divided by time. Please take note. So in a mathematical expression under variation, whenever you have this proportionality, for you to simplify that particular formula, you remove the sign of this proportionality. Please take note. And to remove the sign of any proportionality, we have to introduce a constant value. Please take note. To remove the sign of any proportionality, we introduce a constant value. Okay. Now let's introduce a constant value here. So this is going to be F external will be equal to. So I'm replacing this proportionality to equal as for. I'm replacing this proportionality as equal to. Please take note. So this is going to be K of n into V minus U over T. Please take note. But there's something you have to understand here. For this formula here to be dimensional correct, it means that the right hand side, that is the whole of this guy, must be equal to the left hand side, that is the whole of this guy here. The unit of the right hand side must be equal to the unit of the left hand side. So for the unit of the right hand side to be equal to the unit of the left hand side, we introduce the k to be equal to 1. Please take note. So what will make the unit of the right hand side to be equal to the unit of the left hand side is to make k to be equal to 1. Please take note. So when you do that, we have something like this. F external is equal to 1 of mass into V minus U over T. Please take note. So when you multiply, we have this to be external force is equal to N into V minus U over T. So this is the fundamental formula for Newton's law of motion. Please take note. This is the fundamental law of Newton's law of motion. So before we write down the formulas related to Newton's second law of motion, let's take this note here. Please write. Note that Newton's second law of motion is also known as law of acceleration. Note that Newton's second law of motion is also Note that Newton's second law of motion is also known as law of acceleration. Please take note, okay? So let's consider the formulas related to Newton's second law of motion. All right. Before we consider this formula here, let's write down the fundamental formula for Newton's second law of motion. Class, this is the fundamental formula for Newton's second law of motion. It means that from this formula, other formulas can be derived. Please take note. So now let's write down the formula here. That is the first formula here. Okay, the first formula here is external force is equal to mass times change in velocity over time. Please take note. So please, let's from this formula here, that is from this formula, formula 1, let's get the next formula, that is formula 2. So before we derive or modify the first formula to get the second formula, please, we have to understand this. Note that A is equal to V minus U over T. From equation of motion, we know that V minus U over T is the same thing as acceleration. Please take note. So anywhere you see from equation 1, anywhere you see V minus U over T, we replace A. So I will have my second formula to be F, external force, is equal to N. The whole of this here, class, that is from here, I will replace that as A. So I will have my formula to be A. Okay, so I will call this formula 2. Okay, now the next one here is formula 3. Remember, all formulas are derived or modified from the first formula. Okay, so formula 3. Okay, remember that from formula 1 that external force is equal to N into V minus U over T. If you cross multiply, I will have something like this. External force times T is equal to N into V minus U. Please take note. So force multiplied by time, that is this kind here, force multiplied by time, we call it impulse. Or impulse is the same as change in momentum, which is this here. So impulse can either be written as force multiplied by time, or impulse can also be written as change in momentum, which is mass times change in velocity. Please take note. So these are the formulas we use to calculate most of the equations in Newton's second law of motion. Please take note. So now let's solve a question here to understand these formulas here. Please write question 1. All right, let's solve this question here. But before we solve this question here, let's understand the equation perfectly. Okay, they said a force of 16 newtons, that is, the force here is 16 newtons, applied to a 40 kg block, that is, the mass is 40 kg, applied to 40 kg block that is at rest. We are going to understand when an object is at rest, what it means. Okay, on a smooth horizontal surface. The smooth horizontal surface means that there is no friction on the surface of the object. Okay, now what is the velocity of the block at t equal to 5 seconds? So the time given to us here is 5 seconds. So let's understand the equation here. Solution first. So it means that an object that is a smooth surface, that is this a smooth surface here, class. Okay. So an object is placed on this smooth surface. Let's take this as the object. All right. So the mass of this object is 40 kg. The mass is 40 kg. Now the force applied on this object is, the force applied here is 16 newtons. Please take note. And this object is at rest, meaning that this object is not moving. That is, when, listen to me carefully. There are some statements you should understand in motion. And the first statement, the statement you have to know here in motion is one. When an object is at rest, always remember this. Whenever an object is at rest, it means that U is equal to 0. Now, whenever an object comes to rest or retard, V is equal to 0. So whenever an object moves in a constant velocity, A is equal to 0. So these are the statements with mathematical expression. So whenever they say an object is at rest, it means that U is equal to 0. An object comes to rest, it means that V is equal to 0. An object moves in a constant velocity or uniform velocity, A is equal to 0. Please take note. So that statement that this object is at rest, it means that U is equal to 0. Please take note. So class, let's list out the parameters and know the formulas to use. Given parameters, force is given to us as 16 newtons. Mass is given to us as 40 kg. U is equal to 0. That is an object at rest. All right. Our T is equal to 5 seconds. Okay, class. We are asked to find velocity, that is V. So from these given parameters here, which of the related formulas in Newton's second law am I going to use? Is it the first one, or the second one, or the third one? Is it the first one or the second one? Let me write them down. The first one is this, that is F is equal to M into V minus U over T. This is the first one. The second one is F is equal to MA. This is the second one. The third one is for impulse is equal to N into V minus U, or impulse is equal to F times T. This is the third one. Okay, now this is very, very clear that in the first one here, force is given here, mass is given, time is given, initial velocity is given, and we are asked to find this V here. So how do we apply formula? We apply formula depending on the given parameters and what we are asked to calculate. So the parameters are given here. That is, the force are given, the mass is given, the time is given, and the initial velocity is given. So if you look into the second one here, force is given, mass is given, but acceleration is not given to us, and velocity is not here. Okay, so this last one here is mostly for impulse. So whenever you're asked to find impulse, this is the formula you use. So we are not asked to find impulse in this question here. So now let's use the first formula. Using the first formula here, we have this to be F equal to m into v minus u over t. Let's replace the given parameters. First is given to us as 16 is equal to 4t into v minus 0 over 5. So in mathematics, whenever you have bracket open and close, you simplify what is inside the bracket first before any other step. Please take note. So now let's simplify what is inside this bracket here. Now let's simplify what is inside this bracket here. Okay, class, v minus 0 will give us v. So we'll have this to be 16 equal to 40v over 5. But remember that our intention here is to make v the subject. So to make v the subject here, I will cross multiply to make v the subject. Remember that 16 is the same as over 1. And in mathematics, whenever we have division at the left-hand side and division at the right-hand side, we cross multiply. Okay, now when you do that, we have this to be this will multiply this. I will have this to be 40v is equal to this will multiply this. I will have this to be 16 times 5. Please take note. So class, this will be 40v is equal to 80. 16 times 5 will give us 80. So our v will be equal to class 80 over 40. And my answer is 2 meters per second. Okay. So all you have to do to get the next question on Newton's second law of motion is to hit the subscriber button. Okay. Thank you.